This PowerPoint tells you the basics about arithmetic sequences. Notice it's pronounced arithmetic because it is used as an adjective, not arithmetic when it is used as a noun. Now I'm saying it wrong. Arithmetic sequences are sequences where the difference between successive terms of a sequence is always the same number. This number is called the common difference. Notice that in this sequence that if we find the difference between any term and the term before it, we always get 4. 4 is called the common difference and is denoted with the letter D. So notice 7 times 3 minus 3 is 4, 11 minus 7 is 4, 15 minus 11 is 4, etc. To get to the next term in the sequence, we would add 4. So a recursive formula for this sequence is a sub n equals a sub n minus 1 plus 4. And don't forget the starting term, a sub 1 equals 3. Once again, using the same arithmetic sequence with a sub 1 equals 3 and d equals 4, we're going to establish a pattern now. We know a sub 1 is 3, a sub 2 is 3 plus 4, which is 7, a sub 3 is 3 plus 4 plus 4, 11, a sub 4 is 3 plus 4 plus 4 plus 4, a sub 5 is 3 plus 4 plus 4 plus 4 plus 4. And now we're kind of tired of saying plus 4 lots of times, so we're going to summarize that, and we're going to say 3 plus 4 fours, or 4 times 4. So this would be 3 plus 3 times 4. And this would be 3 plus 2 times 4. And 3 plus 1 times 4. And 3 plus 0 times 4. Notice the connection between the term numbers, term number 1, 2, 3, 4, and 5 in pink, and the number of times that we multiply or that we add 4. For term number 1, we add 4 0 times. For term number 2, we add 4 1 time. For term number 3, we add 4 2 times. For term number 4, we add 4 3 times, etc. So what would we do for term number n? We would add 4 n minus 1 times. So in words, this formula is telling us to get to term n, we start with 3 and we add 4 n minus 1 times. 1 less than the term number. Try using the formula to get the 10th term. Well, we would start with 3 and add 4 9 times to get term number 10. The term formula for the sequence on the last page was a sub n equals 3 plus n minus 1 times 4. Using the distributive property, that simplifies to 3 plus 4n minus 4, or a sub n equals 4n minus 1. If we substitute the set of positive integers, we get our sequence, which we saw before. And the common difference is 4. Now you think, okay, we established all that in the last frame, but here's the point. Notice that the rule for an arithmetic sequence is a linear equation and that the common difference is the slope. Just using 4n would generate the multiples of 4 and give us the sequence 4, 8, 12, 16. But we want the sequence 3, 7, 11, 15, where all of these numbers are 1 less than multiples of 4. So we need to subtract 1 from each multiple of 4. So one way of generating a formula for the term is to use this term formula, which you'd have to memorize or just remember how it works. The other one is just using common sense to look at a pattern of numbers and see, okay, we know that if the slope is going to be the common difference, what constant do we have to add or subtract to get the first term? Okay, so when n is 1, we would get 4, and then we'd have to subtract 1 to start with 3, our starting point. So using the same idea, what's the rule for the sequence 7, 12, 17, 24, and 27? Well, notice that you're adding 5 between each term, so that's the slope. Then each term is a multiple of 5 plus 2. 1 times 5 plus 2 is 7, 2 times 5 plus 2 is 12, 3 times 5 plus 2 is 17. So in general, then the formula is 5n plus 2. Let's write the explicit rule to find a sub n, the nth term of a sequence, an arithmetic sequence, when a sub 1 equals 6 and d equals negative 2. And we're going to review the two different methods I just showed you. For either method, it's helpful to start by looking at a few terms of the sequence. So we'll start with 6, and since we're subtracting 2 each time, we'd have 6, 4, 2, 0, and negative 2. Method 1, use the formula and substitute a sub 1 and d. Okay, so here's our formula. A sub n equals a sub 1, the first term, plus n minus 1 times d. We would substitute 6 for our first term and negative 2 for d. We could also simplify this. Going a little ahead of myself. We could also simplify this into negative 2n plus 8. Remember that our formula says in words, start with 6 and add negative 2 n minus 1 terms to get the nth term. Now method 2 says d equals negative 2 is the slope of the linear equation. Then find the constant c needed to get the correct starting term. So a sub 1 equals negative 2 plus some constant c. Every time I use my cursor, it adds another line here. Since a sub n equals 6 when n is 1, then we would have 6 equals negative 2 times 1 plus c, which leaves us with c equals 8. Or you could think, okay, what if this is negative 2 plus what gives me 6 for my starting term? So negative 2n plus 8. We can check either formula by putting in the first few positive terms and verifying that it generates the correct sequence. And since we've already checked the first term for both, we could say when n is 2, we would get negative 2 times 2 plus 8, which is 4. When n is 3, negative 2 times 3 plus 8, which is 2. And that is what we have, the 6, the 4, and the 2 up here. Okay, here's a problem of a type that you'll encounter sometimes. The fourth term of an arithmetic sequence is 3, and the 16th term is 27. Find the first term of the sequence. So writing the given information symbolically, we have the fourth term, a sub 4, is 3, and the 16th term, a sub 16, equals 27. This is going to be helpful for doing some substitutions later. I also find it helpful to draw a diagram. So I created a diagram where I have blanks for the first 3 terms, so blanks and then 3, and then I keep counting, so this is term number 4, 5, 6, 7, 8, 9, and so forth. And so I drew all these blanks till I get to 27 in the 16th blank. How many differences would I add? You remember, because there's a common difference between each term. How many differences would I add to get from the 4th term to the 20th term? So in other words, how many times am I adding d to get from 3 to 27? Well, if you count those up, you'll find that I have to add d 12 times to get from the 4th term to the 16th term. Or you could figure that out because 16 minus 4 is 12. So in other words, a sub 16 is a sub 4 plus 12 times some number d. Well, I happen to know what a sub 16 is already. It's 3. And I happen to know, or sorry, a sub 4, and a sub 16 is 27, so now I can just solve and figure out what d is. Solve this for d, and you find out that 24 equals 12d, d is 2. This is a pretty simple example, but this is what you would do for any problem like this. The 4th term then is the first term plus 3d. I know the 4th term is 3, the first term is what I'm trying to find out, d is 2, so I can solve for the first term, and therefore I found the first term is negative 3. Since we now know that the sequence is arithmetic with d is 2 and a sub 1 of negative 3, let's write an explicit rule and a recursive rule for the sequence. The explicit rule is negative 3 plus n minus 1 times 2, or 2n plus 1. The recursive rule is a sub 1 equals negative 3, we have to have our starting term, and then for any term greater than 1, for n greater than or equal to 2, a sub n equals 2 times a sub n minus 1. Because each time Oops, that is wrong. I don't think I've ever found a mistake and edited it right in the middle of a video before, but there's a first time for everything. So the recursive rule, notice that we put in is a sub n minus 1 plus 2, because I'm adding 2 each time to get to the next term, not multiplying by 2. That would be a geometric sequence. Okay, so notice here where the first term shows up in the explicit rule and where it shows up in the recursive rule. It shows up as a starting term here in the recursive rule. It shows up here as our a sub 1 in our explicit rule. And then where our d shows up is how many times, what we're multiplying n minus 1 times is 2. Here it's what we're adding to each previous term. And that is the end of your basics for arithmetic sequences.